Okay, so we are going to start a little sort of subunit on relations and functions, and we'll talk about linear functions and absolute value functions, which are the first two graphs we do. Then we go to quadratic functions. So Algebra 2 is the study of functions. We need to know what a function is. So we start with you'll be able to identify the domain and range of a relation. So a relation comes before a function. Then you're going to be able to say, well, is that relation a function? And then the last thing is function notation. Function notation is on standardized tests and all of math really for the after Algebra 2. So there are notes that go along with this. If you want to use them, that's fine. If you want to just take them, that's fine also. So a relation, any set of ordered pairs. I can give those ordered pairs in a table, plotted on a graph, set notation, or a mapping, which I'll show you what all those are in a minute. When we have a relation, which could then be a function, our x values are called our domain, our y values are our range. So x domain input, y range output. You put an x in, out comes a y. So if I gave you that relation, it's a set of ordered pairs. If I said, what is my domain? You would give me all the x's. Now you do not have to state the same number twice. What are your x's? -1, 4, and 7. Range, what are your y's? 2, 0, 3, and -5. Those little brackets, that is set notation. So when I say, like, how do you put these in these different notations? A graph, this is set notation right here. So you have the set of ordered pairs. A graph just means you go and plot them. So -1, 2, 4, 0, 4, 3, and 7, -5 would be down there. Table, you think x, y, -1, 2, 4, 0, 4, 3, 7, -5. A mapping, what a mapping does is, there's your x's, there's your y's. You put your x's, you put your y's, and an arrow goes from the x to the y. That's a mapping. So those are the 4 different ways you could show a relation. What makes a relation a function? A relation is a function if each x has exactly 1 y. So really, the easiest way to say this, x cannot repeat. Because if I have an x and it has a 2 and it goes to a 7, and then I have another 2 and it goes to a 5, this exactly 1 would not be working. So no x can repeat. Now, I didn't say anything about y's. So if you look at this, I mean, this would be the ordered pairs 1, 2, 2, 2, 3, 4, 4, 5. X did not repeat. But for this next one, I have 1, 5, 1, 7, X repeated. So that is not a function. Real world application, July, each day has a high temperature. We take each day and we pair it with its high temperature. So you think the domain would be the days. July 1, July 2, July 3, all the way to July 31. My range would be the temperature. So maybe the first it was 70 degrees. Maybe the second the high was 79 degrees. Maybe the third it was 70 again. Maybe the 31st it was 79 again. Can a given day be paired with more than one high temperature? On any given day, there's only one high temperature. So if you think about this, would your X's be repeating? They would not be. Your Y's might repeat, but your Y's can repeat. So it would be a function. So vertical line test. Big thing you're going to hear for the rest of this year. Vertical line test is a sort of visual test that you can use to tell whether a given graph is a function. A graph is a function if any vertical line drawn goes through the point only, through the graph only one time. So I sort of just draw a lot of these. If I look at this and I say, would a line pass the vertical line test? Any vertical line you draw only touches that graph one time. That is a function. You think of this one, any vertical line. Don't draw that one and say, hey, one time. This touches that graph twice. This is not a function. Now, I use this to sort of show, why does the vertical line test work? Let's say that point is 2, 4. Well, if that point is 2, 4, that point, let's say, is 2, negative 3. If a vertical line touches a graph twice, I have the same X going to different Y's, which can't happen. So that would not be a function. Same thing here. No. Don't go over here and say, hey, yeah, it's anywhere. This would be yes. This, obviously, no. So a vertical line can only touch the graph one time. So next thing, last thing, function notation. So when a function can be described by an equation, we use function notation, which is read as f of x. F of x is taking the place of y. Y equals 3x minus 8 becomes f of x equals 3x minus 8. It's not f times x, it's f of x. To evaluate f of x at x equals some number, you plug that x into the function and you simplify. So don't read it as like solving an equation. If I say, what is f of 5? That 5 is taking the place of x. So I look at my equation and I put 5 where I see an x, and I do the math. 3 times 5 is 15, minus 8, 7. Now, what point would that correspond to? You put 5 in for x, you got 7 out. Okay, so that's really, just think, you're just plugging x in. So I just picked some random ones, but you have to be careful. Like g of x is x, it can be f, g, p, q, whatever. G of x is x squared minus 4x. So I say find g of negative 1. That means I'm going to plug negative 1 in for the function wherever I see an x. Now, do not forget parentheses. So negative 1 squared minus 4 times negative 1. I get 5. Just plug it in my calculator. This next one, I give you an f and a g. F of negative 2 plus g of 0. Well, figure out f of negative 2. 6 times negative 2 plus 7 is negative 5. Figure out g of 0. 3 plus 0 squared. Well, that's 3. Negative 5 plus 3, negative 2. Number 4, be careful with absolute value. Remember what it means. The absolute value of negative 8 minus x is g of x. I say do g of negative 4. That means I'm going to do the absolute value of negative 8 minus negative 4. Do the inside first. Negative 8 minus negative 4 gives me negative 4. The absolute value of negative 4, how many spots away from 0, is negative 4? 4. F of x, x minus 3 over 2, find f of negative 7. Negative 7 minus 3 divided by 2. That, I mean, you can put it in calculator, just make sure you do the top, then divide by the bottom. Answer is negative 5. So you're not solving, all you're doing is plugging in. Last thing, evaluating from a graph. So I give you a picture and I say, find f of 0. Well, this big thing that I say, remember, that's the x. So you're looking at this picture and you're saying, when x is 0, where's your graph? Well, when x is 0, I look down and I see, hey, I have a dot at negative 3. It's a y value. F of negative 2. When x is negative 2, my graph is hitting at negative 6. At f of 6, this is my x. There's 6. Where's my graph? It's at 0. The y value. When x is 4, where's my graph? Up at 3. So just remember the inside is the x. So I think that that is good for today, and hopefully it's not too taxing of an assignment.